Okay, normalization is really just the process of organizing our data in the database that includes creating tables and establishing relationships between those tables, and then elimination of redundant groups or data. And you will find lots of different definitions out there, but there are mainly 5 normalization forms. And we call these by their number and then NF for normalization form. So like 1NF simply means to eliminate any type of repeating groups that might exist. So if we give a definition to that, our first normal form means that data is in an entity format, which means the following conditions have been met. We've eliminated repeating groups in the individual tables. We've created separate table for each set of related data. And we identify each set of related data with a primary key. And if we want to take our data and normalize it to the next degree, we call this 2NF, or second normal form. And this is where we eliminate redundant data. But for something to be in second normal form, it has to meet the criteria of the lower form, the first normal form. So the second normal form has met the criteria of the first normal form, and it ensures that each attribute describes the entity, creates separate tables for each set of values that apply to multiple records, and then relate these tables with a foreign key. Now, records should not depend on anything other than a table's primary key, including a compound key if necessary. So we meet first normal form, and then we make sure there's no redundant data. Now, if we've met that, we're going to go to the next level, third normal form. This is where we eliminate columns not dependent on our key. And to meet third normal form, it has to meet the first 2 normal forms. So for it to be third normal form, we have to eliminate the repeating groups and have a primary key as defined by first normal form. And then we have to eliminate any redundant data, which is the definition of our second normal form. And then we eliminate the columns not dependent on the key. And that's how we reach third normal form. So if we have attributes that do not depend on the key, we eliminate those fields. So values that are not part of the record's key do not belong in this table. They must be put in another table. In general, in the contents of a group of fields apply to more than a single record, put those fields in a separate table. Then we have another form that you sometimes hear, but a lot of times you don't, and that's the BCNF. And it depends on the establishment, but sometimes you will have the Boyce-Codd normal form, sometimes referred to as the 3.5 normal form, and sometimes people will say this is the actual fourth normal form. Now, Microsoft calls the fourth normal form the Boyce-Codd normal form. So that just depends on the organization as to which you want to roll this into. But really, this just designs tables so that every determinant is a candidate key. And just remember what those terms meant. Usually when you get your tables to third normal form, that's pretty good. We usually and rarely ever worry about fourth normal form and fifth normal form. And when you're working with normalization, there are anomalies that you can look for. You can see that relations are categorized as a normal form based on which modification, anomalies, or other problems they are subject to. And you can see that the first normal form, second normal form, third normal form, and BNCF or BCNF can have the functional dependencies anomaly. An anomaly is just an undesirable consequence of data modification which 2 or more different themes are entered in a single row, or 2 or more themes are lost if the row is deleted. And if the row is deleted, we call this a deletion anomaly. If it is 2 or more different themes are entered in a single row and it shouldn't be, we call this an insertion anomaly. We want to make sure to avoid multi-valued dependencies. You might even hear a term when it comes to third normal form. A definition of that is we hear transitive dependencies. So in third normal form, your data is in third normal form if it is in second normal form, as I described before, and it has no transitive dependencies on others. Do we want a database to be updatable or a read-only database? If it's an Updatable database where we can add the information, change the information. We normally want tables in BCNF. You want your tables normalized, so at least up to the third normal form. If it's read-only database, we may not even use our BCNF tables because users can't change the data. We're giving them the data for different purposes that they need. And I have hardly ever seen this because that's why we have our rules and we can set permissions on our databases. So rather than having multiple copies of data out there, which is against what we stand for with database management and having redundancy, we typically take care of things through permissions. So that's why we worry about mainly updatable databases and not having to worry about updating other databases that we've set to read only and then have maybe data that doesn't match up. So you can look into read-only databases on your own, just not a fan of that because that's why we have permissions. But I'll give you a little bit of information on them just for sheer content and giving you a little bit of information to start your research on. Read-only databases are non-operational databases, and this is because we are just using data for these as general information that we have extracted from other operational updatable databases that we have. And they are used for querying, reporting, and data mining applications, but it's only as good as the data at that given moment in time that it was extracted from our operational database. Like I said, these are, you might put new data in, but there's not something you can physically update. The user cannot just go in and, oh, they want to put some more data in there to change their querying. They can't do that. It's read only. And just like you would expect, updatable databases are those operational databases of a company that we actually use, such as an OLTP, which is an online transaction processing system where people are using like credit cards for purchasing. Now, if you're constructing an updated database, then you need to be concerned about modification anomalies, as I mentioned before, and inconsistent data. That's why we put rules in place. That's why we make sure that we normalize our tables so that we try to get away from any chances of inconsistent data. So you must be careful when you're considering your normalization properties, and you want to take them up as high a level as you can. If you had a table that's in first normal form, as we've seen in other examples, you may have redundant data. You may have, rows that are not unique to one another. So make sure you're normalizing your tables when you're creating your databases. These updatable databases are our working databases. This is what we as database managers are in charge of, and making sure that we are ensuring our data integrity and making sure that these function as their highest peak performance that's possible. So make sure that you are constructing your databases carefully and that you're normalizing your data. With most things that we want to make better, there are advantages and disadvantages. So here are those advantages and disadvantages of normalization. Eliminates those modification anomalies I mentioned earlier. Reduces the amount of duplicate data. We do not want redundancy of data. Of course, we want to, when it comes to IT, we want redundancy of many things, but we don't want to see the same data in a table or in a database, because if we have to change it one place, that means we need to know where it's at to be able to change it the other one. So as an example, if someone's last name changes due to like marriage, we want to be able to change that in one place only. Otherwise, we could have problems. We can save file space by reducing that duplicated data and that data integrity problems, as I mentioned before, like with the person's last name. Another advantage is single table inquiries are going to run faster than if we have, if we're going to get like people with the last name of Spock. If we can run a query and the last names are only in that one table that has last names, that's going to be a lot faster than going through and trying to find data that is like Spock. So that is why it's an advantage to normalize. Some disadvantages is you have to know complicated SQL for joining tables or writing subqueries to gather that data that's going to be in those multiple tables. So it's extra work for your database management system. So in theory, it's going to be a slower application because of the amount of time it takes to look at this table and this table and this table and this table to pull that data together. And you might think, oh, well, if I'm used to seeing a spreadsheet and I kind of know where the information's at and I can sift through it. Well, imagine you have 20,000 lines of data there, then it's not so simple anymore, is it? Or if we can write a simple SQL script to grab that data all into one result, now we've saved a lot of time and we have eliminated any type of potential for missing the information if we were just scrolling through and visually looking at it line by line. So advantages and disadvantages do exist with normalization, but you can see that the advantages far outweigh the disadvantages. As an example, if we take a look at this equipment repair table, this is not normalized. You see we have an item number and we have repeating item numbers. We have equipment types, repeating equipment types, acquisition costs. Okay, this is the cost of acquiring that equipment. If there are repairs for the equipment, here is the cost for it. Here's when it was done. Well, these are really two separate items, at least two separate entities. So we have repairs and we have equipment, but this is one table. If we separate that in, we could have our data extracted and reduce some of our redundancy. So if we look at it, separate into normalized tables, we have reduced our redundancy. We see that repairs, this is probably a primary key because these are unique numbers, they're not repetitive. Same way with item number, and we've specified the item number goes to specifically talk about our drill press as our equipment, and here's what we spent in a cost. And then you can see if we had an item number of 100, well, we can see that here as a foreign key in the repair table, yeah, that can be referenced multiple times, but it's tied to individual repairs on that item. So if we were to do this in our previous table, we would have multiple lines of the same data. We would see that we have repair date listed multiple times for this item, or we'd have this item listed multiple times. Where now, if I wanted to do a query against my repairs on my drill press, I could write a query to reference item number 100, and it would pull up the different repair numbers that are associated to item number 100, and it would be, I would not have this other data that I don't care about. So that's why we normalize, and here's an example of how you do that. So this data is not dependent on this data anymore. It is dependent, the repair number is dependent on the item number for being able to reference that that is tied to a drill press piece of equipment. Well, how would we get that data from one table into another? We can use SQL to do that if we are doing it after the fact. And hopefully our database is not too complex. But if we were taking this data from Access, let's say, and we've put it into a table, then we can then change those tables in our relational database management system. And we could use SQL scripts, and here's an insert statement where we could insert into this table, this new table, equipment item, a distinct item number, so we're going to eliminate that redundancy, the equipment type, and acquisition cost. Those are our three attributes for this entity equipment item. And we want to get that information from equipment repair, and equipment repair was our original table. So that's how we are creating that new entity from our original entity that was not normalized. And we can do the same thing for repair to only get the information from repair. Then we can then remove that original table, the equipment repair table, because it's not needed anymore. We've normalized the data. We don't want redundant data, so we completely remove that equipment repair entity from our database. Now, denormalization, never really seen this used either, and I've spoke with other professionals that say they should just throw away that term because it's ridiculous, but it's just the opposite of normalization. So sometimes people say, or by definition, some guru has said that if we were going to use a read-only database for some odd reason, we wouldn't want to normalize. We would want to denormalize our data when we were creating that read-only database. And that's just taking, from our previous example, the two tables where things are separated, we reduce our redundancy and chances of errors, and we join it all back together into one big table. That's all normalization is, a joining the data that's been normalized and storing it in a single area. So it's then going to be in a non-normalized table, and we have to try to forget about the common sense of, oh, well, that doesn't make sense. That's information should be completely separate. Well, if we're denormalizing, that's what we want to do. Here's an example of that. We have student, we have our student ID and our name, and we have activity, and we have a payment entity. These are normalized. The data is exactly how it should be. It's separated based on being specific to an entity. These attributes are only specific to their entity. But then we denormalize that and we just throw it all together. And we can do that using SQL, just writing a script to insert information from these three tables into a single entity that we are going to call student activity payment data. So you can see from the script, we're going to insert into a new entity or table called student activity payment data. We're going to select our student ID from the student table, student name from the student table, the activity from the activity table, the activity fee from the activity table, and amount paid. We're going to say we want it from those three tables, student payment activity, where our student ID is, the values are equal to the student ID in both tables, student and payment, and the activity fields or attributes in the payment and activity are equal as well. And then we get this new table. You see the results listed here. So we're denormalizing our normalized data. When we're designing a database, there's several problems we can have. We can have multi-value, multi-column problems where we've got the same attribute. We have different values of that in the same area. We want to do that. Inconsistent values that, well, as an example, something can be misspelled, where the term, let's say someone had a last name of Steele, and someone put it S-T-E-E-L, and someone else typed it in S-T-E-E-L-E, and it's not supposed to be. We have an inconsistent value. That is a problem that we'd have. We got missing values. Information that should have been entered wasn't entered, like a null value. Let's say someone paid a fee, but someone did not put it in there. Well, that information is missing. General purpose remarks column. You've probably seen this in like Access, where you have a remarks field where you can put little notes in. That's not really a good practice, but sometimes it is necessary. So that's a general purpose remarks column that can create problems in our database. I know that was a lot of data over these two videos, but hopefully it summarized a little bit. Some of it's just really complex, and you're not really going to get it until you dive into it. So I just wanted to give you an overall general kind of an introduction to this information, so that when you're working with relational models and you're designing your database, you're working with your tables, you kind of understand, all right, this data needs to be very defined and should only have related information in an entity. My attributes should only tie to my entities. I shouldn't have things that are of no value in my tables. And then if it's of no value, I create another table, and then I create a relationship between those if it is possible. Welcome to database design, and it is not the simplest of things, but I hope you enjoy doing it, and you make sure to practice with just creating tables, creating relationships, writing your SQL scripts, working with SQL Server or other database management systems, and just enjoy the results you get when something works the way you want to. If you need, you can use like AdventureWorks database. You can just get those as a free download from Microsoft if you're using the Microsoft SQL Server, especially if you're using the Express. You know, it's a much leaner management system. It does have limitations, of course, but go out there and practice, everyone, and learn all you can about database design. Thank you for following along, and have a great day.